We are on a roll, right? Okay, so here's my TLC plate. And then I'm going to draw a pencil line down here at the very bottom. That way my origin line does not interfere with the mobile face or solvent. And I've spotted my sample kind of here in the center. And I've developed my plate. And I see some spots. And let's see, there's a spot here, and let's see, there's a spot there. Well, if you see those spots, good news for you. You don't need an indicator. But most of the time, you're not going to see the spot. Most of the time, you're not going to see anything. It's kind of depressing. You did all of this work. You've prepped these TLC plates. You've prepped your mobile phase. You've chosen the proper mobile phase. You've chosen the proper TLC plate. You've waited 30 minutes to an hour to get these TLC plates to develop. And nothing. No spot. Did you spot it right way? You begin to question yourself. You question your life choices. And then you maybe go for help. And say, what did I do wrong? There was no spot here. I don't understand. The only thing that I see on my TLC plate is where the mobile face stopped. Because I was able to see that. It looks wet. Well, I take the TLC plate out, and then I take a pencil, and I make sure that I draw this line where my mobile phase has stopped. We call this our mobile phase front. I mark the mobile phase front. And then maybe I go ask for help, and I say, what happened here? You know, I put my samples on it. I developed the samples. I did it all the right way. I made sure that I actually injected the right amount of sample because I visually saw it. It works for them. It works for her. It works for him, but it doesn't work for me. What did I do? Well, maybe, just maybe, you have a compound that you can't visually see. That's not uncommon, right? Especially if this compound is colorless. If the compound is colorless, why on earth do you think that you'll be able to see spots from a colorless compound? You can't. If this was a colored compound, you probably would see the spot because it would be a colored spot. Or maybe it has separated into more than one colored spot. But if it's colorless, and this is the majority of the samples that we see in a laboratory, then you're not going to see spots until you do something else to it. So that's where this whole issue of indicators come into play. How do we identify the spots that are on the plate? All right, well, as I look at my TLC plate in the chambers or the beaker, again, I look to see how wet it becomes. And the further this wetness shows up to the top, that means my TLC plate's almost finished. And I'll wait until it gets about to the top, not to the very top, but I'll wait until it gets close enough that I can take it out, stop the mobile phase from getting sucked up, and take a pencil line and draw over here at the very top of it. If I'm lucky, my TLC plate has an indicator built in to the inside of it. Now, when I say that, it's the stationary phase. So remember we talked about stationary phases, and we said there's typically silica and there's alumina choices, and those are typically the majority. 70 to 80% of the time it's silica. But some of these suppliers know that you're going to be injecting colorless compounds on a TLC plate. And the reason that they add the indicator to that is for that purpose. So the stationary phase will typically have a UV 254 indicator in them. This indicator is basically a zinc silicate indicator. And if you have an organic molecule, And most of the time, colorless compounds are organic, and most of the time we are analyzing organic compounds in a laboratory, especially on a TLC plate, then this indicator will be kind of universal for all of those. And the UV254 will basically make all of these organic compounds glow. And they will traditionally glow with some kind of orange spot, or they will be some type of green spot that shows up on the TLC plate, but not in the very beginning, because it has to have UV254 light in order to show up. So as I'm developing this plate, there will be no spots on the plate. I will not be able to see them. Even if it has the 254 indicator on here, I will not be able to see them. Chances are, no, you're out of luck. So what happens is that we allow the plate to dry. Okay, that's kind of the number one rule. Number one, you develop the plate. Number two, you mark the mobile front. Number three, you allow the plate to dry. And then number four, you place the plate on a UV lamp. That's the key. So in a laboratory somewhere, there's probably going to be a very dark area that you'll be able to go to. And there'll be this box. And this box will have some kind of lid on the top of it. And this box will be plugged in to the outlet. And this lid will open up. And when the lid opens up, I can take my TLC plate and I can place it onto the box, and then I can close the lid back. The lid's going to be clear. And then there's going to be a big power button over here to the side. And I flip it on. And then, all of a sudden, what I would see is maybe the presence of some spots. With a marker, I can then go to the plate, and I can then mark the spots that I visually see. So number 5, again, you mark, but this time you mark the spots. This up here was mark the mobile phase. That's kind of the proper way that we develop. Now, the UV254 is not the only indicator that we have, because I said it's mostly universal. It will typically pair up with many of the different compounds that we use in a laboratory, and it works out quite well. The issue here, though, is it doesn't quite work out every single time with everything that we want to actually do. Before we talk about those other indicators, though, I want to talk about this UV light box, because this thing is very important. The UV light box, I want you to think of as a tanning bed. Number one, you never want to look directly at the UV bulbs. Do not look at them, please, because you will burn your eyeballs. This is why they want you to wear goggles in a tanning bed. You should not be in a tanning bed with your eyes wide open, because your eyeballs are going to get burned, just like your skin. So the same thing has to happen here. These are basically super energy tanning bed bulbs. If you lay your skin on this UV light box, you will actually get burned, just like you would in a tanning bed. So you don't want to leave this UV light box on for very long. You want to flip it on, you want to look at your spots, you want to circle the spots, and you want to turn it back off. You don't want to get burned, you don't want to get rash, you don't want to get itchy, and you also do not want to look directly at the light. That's why the cover is present. This cover is basically going to be your safety goggles. These are your tanning bed goggles. That's what I'm going to write here at least. Tanning bed goggles. So never really directly look at the UV light box. All right, now that we've kind of taken that out of play, what if this doesn't work? What if the zinc silicate, this UV254 indicator, what if it doesn't make my spots glow? Well, there's other indicators that we can use, but we've got to do those ourselves, right? We've got to actually prep these. We have to actually go in and put them onto the plate themselves. So there are other indicators, and let's talk about them. All right, so other indicators that I can make, and why would I make them? All right, well, number one, I can use something as simple as sulfuric acid. I can basically spray the sulfuric acid all over the plate, and then I heat it. And what happens is that dark spots can form. This is also a universal indicator, give or take, just like UV254. The sulfuric acid will react with pretty much everything that's on the plate if it's present. And that sulfuric acid will begin to char and burn, basically, the compounds that are on the plate itself. And you'll see those spots and those compounds turn dark. And that's what leads to the spots on the plate. Hopefully you don't get any smears. Hopefully they are spots. So that's one of the other issues that we could do. Sulfuric acid, spray it down, heat it up in an oven, take it out, and we're good to go. Maybe I can visually see the spot after that. Another indicator that's commonly used in TLC is ninhydrin. Ninhydrin loves proteins and it loves sugars. Ninhydrin will typically make things go purple or blue. Whenever you work with ninhydrin in a laboratory, you're going to be stained purple and blue probably everywhere. Your fingers are going to get it. Your clothes are going to get it. The desk is going to get it. Everywhere is going to get it. That's the issue with ninhydrin, because almost everything's got some type of protein or some type of sugar involved. If you're touching the TLC plates with your fingers, well, your fingertips have proteins and sugars on them. That's basically getting transferred over to the TLC plate, and you'll be able to see that when you spray your plate down with ninhydrin. The ninhydrin molecule is going to be like sulfuric acid. You typically spray it down, you heat it a little bit, you take it back out of the oven, and then those spots now have turned color. You can also use other indicators that we've typically seen already in a laboratory. Maybe you've used these with our tests. Maybe you've used these in general chemistry or organic chemistry. But one of these is called bromothymol blue, or BTB. So let me spell that out. Bromothymol blue. Bromothymol blue loves lipids. So this would be fatty substances. These are mainly heavy hydrocarbons that could have some rings, that could have some double bonds, but it's mainly carbon and hydrogen all the way through. It's what we would call fatty acids. It's what we would call sterols. It's what we would call some essential oils, believe it or not. The lipid family is so huge that there's a number of different things that would classify under that. If I'm analyzing organic acids, this would be things like acetic acid and so forth. Organic acids respond very well to bromocresol green, BCG. So bromocresol green. And again, these are for organic acids. When I say organic acids, it's not hydrochloric, it's not sulfuric, it's not phosphoric. Those are inorganic acids. Organic acids would have a lot of carbons or hydrogens on them, and these are typically carboxylic acids. That's the very first kind of category that you think about when it concerns these. And that would be acetic acid, propanoic acid, butanoic acid. Those are the types of acids that we're talking about here. But same kind of deal. You basically spray the plate with the indicator, And now all of a sudden, you'll see some glowing. Sometimes what we spray it with is basically a perfume bottle. It needs to be a very light mist. That's what we're going for here. So we spray it with a very light mist. It settles onto the TLC plate. It will slowly turn that compound into a color. And we normally do this because we don't want to make a mess, right? So we normally do this in some type of spray chamber. And here's a picture of a spray chamber. So it's just basically this chemical resistant box. This is a brand new one, but I hate to tell you, but because you're spraying indicator in this all the time, this will turn really crappy looking in a very short amount of time unless you keep it super clean. But here's the TLC plate in the center. So the TLC spray chamber will basically keep all of those indicator solutions inside of a contained space. That way you don't make a mess out of the laboratory. And over here to the side is just kind of a recipe on how to get a plate to develop. So in this case, it's a 50% sulfuric acid and water solution. Put it in the spray chamber. You're going to basically spray it all over, and then you heat that plate at 240 degrees for 10 minutes. And this will leave those black or dark spots on your plate wherever those organic compounds are. There's multiple recipes out there. So for instance, down here at the bottom, instead of a 50% acid, this is going to be a 40% acid. And this person added 5% potassium dichromate to it. And that will make it kind of turn orangey brown color. This potassium dichromate is basically like a catalyst. It helps increase the sensitivity. It increases the speed. It can actually go to lower levels sometimes. And it doesn't take as long to develop a plate if you've added potassium dichromate to it. So numerous recipes. There's not one way to fix anything at all, right? And whatever you decide to do in a laboratory as far as TLC is concerned, just follow the directions it's given. But keep in mind, there's multiple recipes that will get you to develop all of these spots onto a plate.